So, throughout the history of mankind, we have been asking some really big questions. Like, does the earth revolve around the sun or the sun revolve around the earth? Why do we have high tides and low tides? How do rainbows appear? Why do we have days and nights? Why do we see the lightning before we can hear the thunder? And today we know that all these questions can be answered through physics. And that's why physics is known as the science of natural things. Now we have 6 branches in physics: classical mechanics, electromagnetism, relativity, quantum mechanics, optics and acoustics, and thermodynamics. And in this video, we'll be focusing on some very basic fundamentals of classical mechanics. So let's begin. Now last year I had the chance of going on a road trip from Mumbai to Goa. And when I was back, my friends asked me how was it. I told them that it was super fun and exciting. But if they had asked me to give a number, I wouldn't be able to tell them. And that's because feelings like excitement, thrill, love, hate, anger, they cannot be measured. But if they wanted to know what distance I traveled and how much time, I could have told them that I drove for 640 kilometers in 10 hours. That's because quantities like distance, time, mass, energy, force, they all can be measured. And this is exactly what makes science verifiable. Now to take any measurement, we need units. And the units we choose depends upon the scale of measurement. For example, if we want to measure length, like the thickness of thin sheets, we would use millimeters. To measure small objects, we would use centimeters. To look at track events in your school, we would use meters. Or to measure the distance between two cities, you would use kilometers. But if we increase the scale of measurement, like to measure the distance between two planets, we would use astronomical units. And to measure the distance between two galaxies, we would use light years. Similarly, to measure time, we would use seconds, minutes, hours, days, months, years, or even millennia. And to measure mass, we would use grams, milligrams, kgs, tons, or even solar mass to measure heavenly bodies. Now, students often ask me that, sir, what is the importance of these units? Why do we study them in so much detail? And here I would like to talk about the NASA Mars Orbiter, which was launched in 1999. Now it so happened that during the last phase of landing, the planned trajectory was 226 kilometers. But because of a very small error in the conversion between miles to kilometers, the actual trajectory turned out to be 57 kilometers. And due to this, there was a crash landing and the orbiter was destroyed due to heat. This resulted in a loss of $125 million to NASA. And that's why we professors stress on the importance of units, and you must always write them. So let's learn about some very basic fundamental quantities that make up the foundation of classical mechanics, starting with mass and weight. Now in daily life, we use these terms interchangeably. For example, if someone would ask you your weight, you would say it's 60 kgs or 70 kgs. But what we don't realize is that this is the mass that we are talking about and not weight. In physics, mass is strictly defined as the amount of matter in a body, whereas weight is defined as the amount of gravitational force acting on a body. Mass is measured in kgs, whereas weight, being a force, is measured in newtons. But then you would be like, hey, my weighing scale shows me my weight in kgs, right? Now that's because even though the weighing scale measures the gravitational force, it calculates the mass internally and displays it. Now the issue here is that if you would use the same weighing scale on different planets, it would show you different readings. On Earth, it would show you 60 kgs. On Mars, it would show you 22 kgs. And on Jupiter, it would show you a whopping 150 kgs. Now that's because the gravitational force is different on different planets. But now if the weighing scale is not reliable, then how do we measure mass accurately? You would be surprised to note that the traditional beam balance is an accurate way of measuring mass. Now that's because in a beam balance, the amount of matter is compared in the two pans. independent of the gravitational force. And hence, no matter which planet you are on, it would show you the exact same reading on each of them. Now, because mass is constant in the entire universe, mass is absolute, whereas weight, since it changes, weight is relative. Now, let's talk about two other fundamental quantities in mechanics, distance and displacement. Now, when an object travels from one point to another, distance is defined as the actual path length traveled by the object, whereas displacement is defined as the shortest path length between the initial and the final position of that object. Let's understand this with an example. Now, as I had mentioned before about the Mumbai-Goa road trip, the route I had chosen was through the NH48, that is the National Highway via Pune, represented by this purple line. So the actual distance travelled by me was 640 kilometers. However, if we calculate the shortest distance between Mumbai and Goa, represented by this brown line, it would be 560 kilometers, which is the displacement. Now this is about the one-way trip. However, if we talk about the round trip, that is from Mumbai to Goa and back to Mumbai, the distance travelled would be double of the original distance, that is 1280 kilometers. But since I was back to Mumbai, my initial and final position is the same, making my displacement 0 kilometers. And this essentially is the main difference between distance and displacement. Now, even though distance and displacement are both measured by the same unit of meters, they are two different quantities. Also, since distance is independent of the position of an object, distance is an absolute quantity, whereas since displacement is dependent on the position, displacement is relative. Now, when an object is moving, it's obvious that the distance and the displacement is going to change. And here we introduce speed and velocity. Now, speed is defined as the rate at which distance changes with respect to time, whereas velocity is defined as the rate at which displacement changes with respect to time. Let's look at this in more detail. Coming back to the road trip example, if I had to calculate my speed using the formula distance upon time, my speed would be 640 kilometers divided by 10 hours. That is 64 kilometers per hour. Yes, we know that the SI units of speed and velocity is meters per second, but here we will be using kilometers per hour for the sake of convenience. Now, if we have to calculate the velocity using the formula displacement upon time, my velocity would be 560 kilometers divided by 10 hours, because the displacement is 560 kilometers from Mumbai to Goa, giving me a velocity of 56 kilometers per hour. But in the round trip, things get a little trickier. My speed would be 1280 kilometers divided by 20 hours, because it would take double the time to cover double the distance, giving me the same speed of 64 kilometers per hour. However, since my displacement is 0 in the round trip, as discussed earlier, velocity would be 0 kilometers by 20 hours. That would be 0 kilometers per hour. Now, even though speed and velocity, they have the same units of meters per second, they are two different quantities. Also, speed is absolute, whereas velocity is relative. Now, we have seen the rate of change of distance and displacement. But if velocity also changes, we call it acceleration. Now, we all know that every vehicle has an accelerator, and when we step on the accelerator, the speed increases. For example, if the speed increases from 0 to 25 meters per second in 5 seconds, the acceleration would be 25 divided by 5, that is 5 meters per second square. Now let's do a quick recall of what we have done today. We have seen how physics is the science of natural things. We looked at the different branches of physics, how measurements and units make science verifiable, the different units of length, mass and time, and the fundamental quantities in mechanics like mass and weight, displacement and distance, speed and velocity, and finally acceleration. Thank you.